Okay, hi again guys. So in this video, which is part 3, we are going to learn on how to use Simpson's rule in order for you to solve the residence time and then variance. Okay, let's go through on this example to calculate ET and also variance and mean residence time. Right. So we have a tracer that being injected as a pulse to a rector. Okay, so this is one of the keyword. And the effluent concentration was measured as a function of time, resulting in this table. So you can see here at given t, this is the response concentration, right? So this question asks you to construct figure on CT and ET as a function of time. So let's have a look on the solution. Right, so the same table, so I do back here again. So it's actually you wanted to have to plot this kind of graph. Okay, so it's concentration versus time. So if you plot this data, you will produce this kind of graph. Okay, the next point is on how to produce the residence time distribution function, which is ET. Okay, again, previously ET is actually CT over the integration of CT dt from 0 to infinity. So we need to solve first. We need to solve first for this value. Then only we can produce the ET. So when how to solve this integration of CT from 0 to infinity? So we use, this is what we call it, the Simpson's rule. Okay, this is when we apply the Simpson's rule or Simpson's method. Okay, I'm pretty sure that Prof Zin have shown you some of example in using calculating your rector design using Simpson's rule. Okay, so for this data you can see this is 0. You have two kind of H, right? 0, 1, 2, 3, 4, 5, 6 until up to 10, which is the H is actually H is equals to 1. So in the second part, the H is actually equals to 2. Okay, 12, 10, 12, and 14. So what you can do, okay, so in this video I'm going to explain to you on how to do this calculation. Okay, this is where we apply the Simpson's rule. Okay, so what is Simpson's rule? Okay, just some definition back on what is Simpson's rule, on how to use Simpson's rule to solve your numerical method. All right, so we have so we have, this is the type of Simpson's rule that you can use for your calculation. Trapezoidal rule, which have 2 points. Simpson's 1/3 rule, 3 points, and Simpson's 3/8 rule, 4 points. 5-point quadrature formula, 4n plus 1 point, which also for n plus 1 point. So you may choose one or two of this type of Simpson's rule. Okay, so the first one, trapezoidal rule, is actually for 2-point data. Okay, for instance, you will have x0 and x1, so you use this formula, right? So the next one is Simpson's rule, third rule. Okay, if you have 3 points, so x0, x1, and x2. Okay, so this is like x0, x1, x2. So you use this Simpson's rule, right? And then the third one is Simpson's 3/8 rule, where you can use for 4 points. Okay, 4 points. So it's x0, okay, x1, x2, x3. Okay, so if you look here, the H must be similar. Okay, right? H meaning the difference between one data to another data is equal. If let's say x0 and x1, the H is equals to 2, so this one must be equals to 2, right? And then the next one, the next type of Simpson's rule is 5-point quadrature formula. So this is where 5-point you have x0, x1, x2, x3, and x4. Okay, 1, 2, 3, 4, 5. Okay, so the other type of Simpson's rule, it depends. Okay, if you have more than 5, so you can use directly like this one. Okay, so this one is for n plus 1 point. This one is also n plus 1 point, where your n is even number, right? So let's look back at your example. Okay, so initially the question giving you data T and CT, so we wanted to produce the ET curve, RTD function. Okay, so you need to have the ET points. Okay, this is the ET point, RTD functions point. So in order for you to have these ET points, okay, so that's why just now I show you on how to calculate this CT using Simpson's rule, right? And then by using the Simpson's rule, then you get the this value. Okay, right? So once you get this value, then you insert into one by one of this data. So for instance, how you get this one is actually by applying that formula, the RTD ET formula. So what is this? What is CT? Okay, so you applying this formula, okay, to here, right? So in this case, your CT is equals to 1, right? CT is 1 over the integration of CT is actually 50. Okay, so that's why you get 0.02. So next for this data is actually your ET is equals to, okay, 2 over 50. Then you plug in into this data, right? And then once you finish, so you plot this graph, so ET versus T, so you will get somehow like the same curve like the one that we have earlier in okay, for the concentration curve, right? Okay, next is I want to show you another example. Okay, in your book, these are the data that they gave. Okay, remember this the last time that in the previous video I used this data to calculate the ET and also the mean residence time and also the variance. Okay, so from this data, if we want to solve using the Simpson's rule, so you look how many points do they have. So the first thing you have to look whether they have the same H. What's the H? So it's 0, 2, 4, 6, 8, 10, 12. So meaning the H is 2. Okay, the difference between one data to another data is 2. So we in this data we have 1, 2, 3, 4, 5, 6, 7. We have 7 points. Okay, so you can choose. Okay, if either you can choose 5 points plus 2 points. Okay, or you can also directly choose the like this one. Okay, like this in your book they choose this this type of Simpson's rule. Okay, so this is the formula, so you apply the formula, okay, in order to solve, meaning for this one is actually is calculating from 0 to 12. Okay, so your CT dt, so it will be you just follow that number. So H is 2 over 3, and then what is your F naught? F naught is your CT, the response is 0, okay, plus 4 is 1, okay, and then 2 F2. So this is F naught, this is your F1, so this is your F2. So times 4. So you continue with the rest of the data and then you sum it up. So that's the final answer. Right. So there's another example, okay, the one that I use in this, mostly in this slide note. Okay, you have this kind of data, the T, the response of concentration at T, right? So if you look at here, you will have two different H. So this is H1, this is H2. Okay, so you cannot combine it. You cannot do from, you cannot do like this, from 0 to 14, okay, CT dt. You cannot do like this because it have different H. So you need to split it up. Okay, the first one is using the H1 and the second one using the H2. So the H1, the H is actually what? The difference is 1, right? H2, the difference is 2. Okay, so solve this one and then just, total it up. And then you will get and then you will get here the integration of CT for that data from 0 to 14. Okay, right? So for the same example, you're going to calculate, you get your ET. Now I would like you later to solve for your mean residence time. Okay, and also variant using this example. Okay, using this example. So I would like to see that. So maybe I will ask Prof Zin whether you can submit to me the answer as an assignment, right? And send me to my emails. Okay. Alright, I'll stop here. See you in the next part of the video and on giving you another new subtopic on this chapter 5. Okay, see you in the next video. Bye.